So today we will perform the experiment, and the aim of the experiment is to determine the Poisson ratio for rubber. And the apparatus we use is a rubber tube with metal sleeves and a rubber stopper, and fitted with a hanger at the lower end, and a glass tube, graduated glass tube. Somewhere you will see a capillary tube attached to the other end, but we will be working with the glass tube, graduated glass tube, few slotted weights and a vernier caliper. So what we need is the whole apparatus looks like this. You can see tube. Okay, this is, now you can see this is the graduated glass tube. Okay, and we have the rubber here. Rubber tube is this one my rubber tube, and you can see here that at this end we have, at the end of the rubber tube, we have a pointer indicating on the scale. Okay, and then this is where we will slot the weights using this hanger, and we will put the weights like this here, and then we will hang it here. Okay, this one. So this is what we need. We need this whole apparatus in which we have a scale, and which is pointing at the end of the rubber tube, with a pointer at the end of the rubber tube, and on the rubber tube we have a graduated cylinder in which we have water, and we have this hanger and some weights. Okay. So since the Poisson ratio is defined as the lateral contraction and longitudinal elongation, that means what I have is like is a kind of you can see, if I have let me first kind of, if you see, if something is like this, and then this is my lateral strain, and this is my longitudinal strain. So this becomes, if this is a kind of the ratio which we are taking here, and the formula is half 1 minus 1 by A dV by, or basically dV by A dl, where dV is the small change in the volume of the rubber tube here, and dl is small change in the length of the rubber tube. Okay, and capital A is the area of cross section of the rubber tube, because we will find out the diameter using the vernier caliper, and so from here we will find the area of cross section of the rubber tube. D is the diameter of the rubber tube. So first thing we will do is to calculate the diameter of the rubber tube, and for which we need a vernier caliper. I think you all know how to work with the vernier caliper. This is my vernier caliper. I'm not going to demonstrate how to take the reading from the vernier caliper. But first you need to take the least count of the vernier caliper and the zero error of the vernier caliper. Okay, these you must know already, how to take the least count and the zero error of the vernier caliper. Okay, so this is my vernier caliper, and this is the table where you need is main scale reading, and the vernier reading, and you know the total reading is the vernier reading multiplied by the least count, and this is then added to the main scale reading. Main scale reading is A, vernier reading is B, and then the main scale added to the vernier scale multiplied by the least count, and that will be the total reading. So we will take some reading to any direction, and then like these three readings are any direction, and these three readings are perpendicular to these directions. So any diameter, along any diameter these three readings are, and then perpendicular diameter these three readings are. So you know, this is my rubber tube. So how you take a reading, I'll take a reading like this. If I am doing like this, taking the reading, you have to properly adjust to the diameter, and then you take it out, and then you try to see what is the reading, and then if this is my any direction, okay, so this will be my perpendicular direction. So at one place we'll take any direction reading, and then on the same place we'll take the direction perpendicular to that. So what you do, you take one reading at this end, one reading at the middle, and one reading at the end of the tube, so that you cover up all the length, and you notice down these main scale reading, vernier scale reading, and try to find out the total reading. So this is how you find the diameter of the rubber tube, which ultimately comes in our case is 2.945. So I'm not going to demonstrate how to take the diameter of the rubber tube using the vernier caliper. This you already know. So let us move to the main observation table, in which we will try to find out dV and value of dV and dL. Okay, so you can see the observation table here. It's a load on the hanger and the reading on the pointer P on the scale S1. What is this? This is reading of the pointer P. This is my pointer P on this scale. Okay, we have to note it down, and then this is when we have to note down the reading of the pointer P when the load is increasing, and then the second one is load is decreasing. So what you have to do, we have first there is no load, 0 grams, then we have to note down the what is the load reading on the pointer P. Then we will increase the load by 500, note down the reading 1000, 1500, 2000, 25,000. Okay, then you go to 3000. Okay, then from 3000 you just decrease the 500 grams so that you reach to 2500 grams, and then you note down the reading. Then again you decrease 500 grams, 2000, then again you note down the reading. This is this column, that is why you say load decreasing. Once you do load increasing and then load decreasing, and then you take the mean of these two. This gives you TL. Okay, so which is the change in the small change in length in the rubber tube. So when you put a weight on this hanger, so what you do, the length, what happens that the length of the rubber increases. Okay, and then correspondingly reading of the water meniscus. Okay, similarly for the load increasing and the load decreasing. So when you put a load to this rubber tube, what happens, it increases, and then you can see the level of the water. When I put the load, then the level of the water will increase. Okay, so I have to also note down the level of the meniscus of the water, okay, in this graduated tube. So similarly for the load increasing, and then if we decrease the load, it will come down. Okay, similarly. So that is why these all observation we have to note it down, while load increasing and the load decreasing, for increasing in or decreasing length of the rubber tube, and the increasing and decreasing meniscus of the water. Okay. So starting, if there is no load in here, have attached no load, then we will find the reading of the pointer on the P scale. You can see this is the pointer, this is 2, this is 4, so this is exactly matching at 3. So this is 3 centimeter when there is no load, and similarly you have to note it down. What is the meniscus of the water? You know that is this is 13. Take it very carefully. Be perpendicular. This is 13 point, and this is 12. This is 12. So this is 12.5. So this is 12.5. And then this is 12.678. This is, you see the meniscus is here, so this is almost, you can see. So you can see the meniscus reading is, you see this line, this is, you have to see the perpendicular. So one is here. So we have to take this one. So this is 12.5, 6 and 12.7. You can see 12.5 and 12.7, or you can, from this you can see 4. Okay, this is 13, so 12.7. Okay.